Hi everyone, welcome to today's discussion. I have two very special guests with me, and before I introduce them, let me give you a quick introduction. I'm Krishna. I'm the founder and editor of OTTverse. We are a magazine that's dedicated to video streaming. We talk about everything in the video pipeline, starting from compression, packaging, ad insertion, DRM, delivery, playout, the whole pipeline. So we have interviews, we have deep dives, a lot of tech news. So do check us out on OTTverse.com. So before I introduce my guests, a bit of a background on why I chose this topic. So I've done a bit of compression myself. I did research, I did codec development. And whenever I would do literature review, one name would pop up very often. And as you might have guessed, that's the Fraunhofer HHI Heinrich Hertz Institute. So I decided let's kick it off with a group which has been quite involved in all the codecs that we're familiar with, H.264, HEVC, and now with VVC. So we'll talk about more about the institute itself. What is it? What drives it? How does the decision-making process take place? And their thoughts on the VVC. They have an implementation of the VVC which is open source. Plus a few philosophical questions, I guess, on compression. So let me introduce our guests. We have Benjamin Bros, who's a project manager in the image processing department of the HHI. Hey, Benjamin, thank you for joining. And we have Adam Wieckowski. I know I messed that up, Adam. Sorry for that. Who's a research assistant at the HHI. So let me hand it over to both of you for quick introductions. Benjamin, you first.
Yeah, thanks, Krishna, for inviting us. It's a real pleasure being here. Yeah, my role is the head of the video coding systems department at Fraunhofer HHI, and in that function, I was the editor of the HEVC standard text specification, as well as for the versatile video coding VVC specification text, and also as the whole group or even our department. There are some more groups involved in that. We contributed technically contributed to the standards by contributing compression algorithms. Also, we are active in administrative support, so we host the repositories of the reference software, and yeah, and Cordy, so one of our colleagues, Carsten, is software coordinator for the reference software, and yeah, my role is heading the group that also implements the VVC standards, as well as coordinating and being the editor at the standardization activity itself.
When you said editor of the entire spec, my first question was, has anybody read the entire spec cover to cover?
You'll be surprised. Yes, since we also have a bug tracker where you can find bugs, and we get a lot of feedback from the people working at companies implementing the standards, and they find places that are, well, really, people they really look at each part and each text and each bullet of that specification in order to make their products compliant. That's really amazing.
That's wonderful, because I'm usually stuck at the first page where like, this is what must means, this is what shall means. I'm like, oh God, now to keep all of that in mind while reading the spec. So,
yeah, that whole started. I guess the basic structure is the same since H.264 AVC. So if you went through the pain of familiarizing yourself with the way the spec is written, it's not changing to the newer specs. So once you did that for H.264, you can use that knowledge to read H.265 HEVC as well as H.266 VVC.
Fantastic. Adam, your introduction.
So first, hey Krishna, thanks for the opportunity of being here. So you got my name almost right. So That's great. So I've been at HHI for around 5 years. I started just as we were starting off the work towards VVC standardization, and contributed here and there some aspects with the standard. Also, I was involved with the software, so we developed our own software, which then became the basis for the VVC reference software. And for the last 2 years, I've been doing the technical coordination for the development of our encoding and decoding software, VVenC and VVdeC, which I guess we want to discuss a little bit more later, right?
Yeah, so we'll have some questions on that. Okay, thanks for those introductions. I guess my first question, Benjamin, to you is, so what is the HHI? What is Fraunhofer? What is HHI? What's the relationship? What do you actually do there? Is it like a company? Is it a research institute? If you can give us a little more insight into what happens at the HHI.
Yeah, that's a very good question, because that's always the question. What are you? Are you an institute of an university? Are you a public institute? Are you like a government agency? Are you a company? And the answer is a little bit of everything.
Okay.
So our institute is called Heinrich Hertz Institute, all about telecommunications. And this shows you that there are maybe other institutes within the Fraunhofer society that have different focus. So if we go one level up at the Fraunhofer Society, what is that? So Fraunhofer Society, or Gesellschaft, as it's called in German, is the leading organization for applied research in Europe. And so it's a research organization that number, don't pin me down on the exact number. At some point of time, it was 72 institutes and research units in Germany. And all these research institutes and units have cooperation around the world. The staff members, so just to give you some numbers about the size of that, at that point of time, of course, it's changing. It was 26,600 staff members.
Wow.
So it's quite a huge organization. At that time, the budget was 2.6 billion euros. And from that research compound, some highlights were the MP3 audio codec, which was the Fraunhofer IIS Institute in the south of Germany, in Erlangen. The H.264 you already mentioned, H.265, VVC video codec. We also did, together with the IIS, contributions to LTE and now 5G mobile communications. This is also where our institute is involved. And yeah, the focus of each institute from Fraunhofer, where the institutes, the research focus ranges from health, environment, over life science, mobility, transport, energy, production and safety, IT security. So there's a broad range of research fields within Fraunhofer that is targeting to support companies and industry, as well as the service sector and public administrations with research and development services. So if, for example, one public administration has a problem in some of our expertise areas, but they don't have an R&D department, they say, well, we have that problem. Could you take a look and provide us a solution for that? And that's what we do. And for these kind of projects, we also get support from German government, which is a way for them to support these services, or these kind of R&D services that we offer.
That's very interesting. So are there academic roles as well? I mean, I've seen positions. I'm not sure it was right at HHI, but PhD positions and like Adams and research assistant. So is there active academics also going on where somebody could come in as a master's, do a PhD, publish, go into the industry, something like that?
Exactly. That's the other important pillar of Fraunhofer.
Okay.
That typically we have the head of the institutes or also head of departments also have a chair at the university. So they're also a professor.
Okay.
And having that close relationship to academia, they can also tutor master students, bachelor students, and PhD students.
Okay.
And that's why with the applied research we are doing here, we are offering also students to do their bachelor, master, and PhD thesis in cooperation with my colleagues who also are professor at the university. So this is where we have close ties to academia, and of course our research we publish. One very nice thing that I learned recently is that when we publish something, Fraunhofer also gives funding to make that open access. So everything that we publish, for example, we try the best as we can to make everything open access, so people can just read it without subscribing to expensive journals.
Yeah, that's pretty important, because I remember clearly when I was in university, it was very easy for us to download papers, and that happens in a few companies, but not everybody can afford the cost to actually download these journal papers. It is quite cost prohibitive, I would say, especially when you don't know that's the right paper.
I also, if you want to share something, you send the link to somebody outside your organization. And, well, it asked me to pay like 200 whatever.
Yeah.
Okay, I see.
That's true. Yeah, but that's a great effort actually to make it open access. That would help a lot. I guess this is kind of a segue into something we spoke about the other day, where you mentioned that somebody has to pay for all your lights to stay on. And being a research institute, I mean, everybody who has done research knows that not every idea is going to work out. I mean, you might think that you're on the right track, and at the end of the day, somebody else has already invented it, or it's giving you the exact opposite results. Right? So, how do you, as an institute, prioritize? I mean, if for a company, it's pretty easy. So we say that, hey, this codec has to run in real time. So I might sacrifice a few tools here and there and turn off some knobs. But how do you approach it? I mean, do you see a payoff, or is it just research for the sake of research? What goes on the back of your mind when someone says, hey, I want to improve Quebec? What do you do then? So
yeah, I guess here it also highly depends on who you're asking, right? If you ask the very technical colleagues with a clear research focus, and I think, well, I'm super psyched by these techniques, and I really want to push the capability or the compression capability and get to investigate more what's behind that, and then other colleagues are caring about that what you do should have an impact, meaning being used in standards and devices out there in the world. And we are in the favorable position to that we can do both. So with the success we had with previous standards, that revenue that we get from there, we can reinvest, and not because we are a public research institute, not in our shareholders, but in our new ideas. The whole system is pretty complicated, but the bottom line is whatever we get from our past success, we can reinvest to research without having a clear narrow focus on commercialization. So we can just explore that direction. And even in the past, since you mentioned Quebec, there were a lot of people at that time saying, Are you crazy? This is
Yeah,
super complex. It won't run on a computer. You have to have like super fast hardware. It won't run. It's super complicated. So at that time, there were like two ways to do entropy coding. One is a pretty simple one based on variable length codec with adaptive code word switching and so on. And the other one is CAPEC. And now CAPEC runs on your netbook. Basically on your phone it's running. So this is how it can change. And but at that time, if somebody would have said, well, this is commercially, like the resources you need for that, that's commercially completely nonsense, stop that, we wouldn't have that very efficient entropy coding method. And that's why we have the freedom to explore what's beyond. And that's what we currently do in cooperation with my colleagues from the other research groups. So they can look in video coding structures beyond what we do now, which is now, even in VVC, we started things with having a complex neural network for some prediction modes. And that was too complex. During the course of standardization, we simplified it to be a matrix multiplication. But we never would have come to that place to have a very efficient matrix multiplication if we haven't played with the super complex networks before. So that freedom that we have also allows us to investigate directions where not everyone would go.
So, I mean, how much pushback did you face from chip manufacturers during the standardization? I can imagine neural network on a chip and they leave the room. So,
yeah, it's the discussions can get quite heated, but at the end, I guess you're having a beer at the bar, since everyone is just doing its job, right? Yeah. So we want to get our great compression ideas in, but chip manufacturers have to make sure that it's implementable and that the chip does not cost like 30 euros for low cost devices. So that's the challenge, and that's the beauty of that international standardization, that everyone involved from the ecosystem is there when the technical structure or when the technical aspects of that standards are being developed. So we bring our crazy ideas, and then they have to somehow bring us back down to earth, saying, well, we need to work on that, and then we work on that, and that's sometimes it's frustrating. Sometimes there's a big discussion, there's some fighting, but at the end we come up with something that is implementable and efficient, and that's the beauty of that process.
I think I'll circle back to this question at the end, but probably switch over to Adam at this point. I guess most of the people who are going to be watching this video are quite familiar with the reference implementations, HM, JM, VTM. And reference implementations are, as the name suggests, reference. Right? No one expects to use them commercially. You use them to see whether how the tools work. You can use the decoder to check if your stream is conformant, just to get an idea of the codec and how it's written. Some people might use it as a starting point, but they're not commercially viable. But this time you have taken the effort and probably the impetus to build out VVenC and VVdeC and make it open source. So what was the thought process behind all this? And if you can give us a glimpse on the roadmap, where are you going with this? Because I really saw some interesting features like frame level parallelism, SIMD. So all these are expected in commercial codecs. So what's the thought behind VVenC and VVdeC?
So I think we started with exactly the thought that you just mentioned, that the reference software, it's not viable for practical use or commercial use. You know, it's only viable for like people who want to cross-check their stuff, or for some very, very early demonstrations. So, you know, we knew that once the VVC is done, we want to be able to do some good demonstrations. And we also wanted the standard to be accessible to everyone. And this requires for tools to be out there. So like for a decoder that works, you know, on that can play it out in real time. And for an encoder that can encode the content in a amount of time that is available to a person who doesn't have a high performance cluster to encode the 10 seconds of video. Ben.
Yeah, I maybe to give a good comparison here, what you you're probably familiar with X265 for HVC. So this is what we had in mind, to have people are using that all over the world. If you want to have a free available HVC encoder, there's X265, and that was our idea. And since like a VVC equivalent, X266 is still a little bit far on the road. We thought, well, let's have something directly from the start that is open, available, and accessible to everyone, with the main focus to do not make compromises on the efficiency.
But when you say don't make compromises on the efficiency, is it going to have, I mean, it already has different levels that you use, like the FFmpeg, like super fast, where it kind of helps both ends of the spectrum. Somebody wants to do quick and dirty encoding, they get it out. Somebody wants to reduce their home library into a small disk, they can use the placebo, or not the placebo, but the very, very slow modes.
Yeah, that is a very good point, and yeah, maybe I can share you one slide.
Good.
And Adam, you can walk us through that slide where we exactly measured what you described, the different trade-offs. And I was talking about the slowest setting. So the slowest setting, we don't want to compromise on the efficiency. So let me share that. Go. Yeah, you should see that now.
Yeah, we can see it.
Yeah, so it's just as you mentioned. So we configured a few presets that you can choose, like depending on how much time you have to encode or what's the quality you're looking for in your encoded video. And the idea behind is that with the slowest configuration, we always want to match the VTM software. We want to be able to provide, everything that VVC promises, which is basically what the VTM encoder does. And as you see, even with our implementation, it takes a lot of time. But then we really put a lot of work to implement speedups. When you implement speedups, you cut corners, right? So you cut testing of modes, stuff like that. So of course we have drop in the quality, but we really went a long way to ensure that the trade-offs are really, really good. So we run a lot of tests to see which tools to enable when, which speedups to activate or deactivate when, so that the points that you get, the presets, are really as fast and as good as they can be. Still, with every new release we have, like also you can see here, we are able to improve those points. So we still find places where we can do better. So as you can see, between the 0.1 and 0.2 version, the trade-offs improved. So basically, if something is farther left or farther down, like if a point is farther left or farther down of another point, it's better. And for the version 0.3, the presets are going to be improved even further.
Okay.
But yeah, we're putting in the work, and we want to provide those opportunities to use those very optimized settings, as an open source package.
Very nice. So, sorry to just clarify, is this fixed QP or any rate control which is going on here?
This is fixed QP,
okay.
But at least our two-pass rate control provides very, very similar results.
Yeah. This is very, very nice. So how is the implementation going on? Is it are you inviting participation from the public, or is it more internally from HHI but being released as an open source?
Yeah, so to pick up the question, the idea from before. So as I mentioned at the beginning, the reference software was actually based on a software that we developed at HHI. So because we're so familiar with it, we picked it up for the development. So our implementations are based on the VTM. And in turn on our previous software. So this allows us to do very fast-paced development because we're very familiar with the software basis. And it's also very easy to work with. And we're making most of the development internally. That is, we have people working on aspects, and we're releasing those versions to the public. But in the public space, in the GitHub repository, we also accepting external contributions. So we already had a few contributions to the decoder and one or two to the encoder that we then, incorporate into our internal development and basically keep as a part of the, of the distribution.
That's very encouraging. Because, I mean, like you mentioned, people need something to play with and to get used to the codec. Otherwise, these codec comparisons are endless. This is better than that.
So one other aspect there, what we see is that we provide and make public like the basic functionality that you need. For example, if you want to do cloud-based encoding, if you want to do HDR video, if you we added tools for screen content coding, but then there are use cases beyond that. For example, 360 VR, AR video, and there are a lot of people out there who wants to play with that. So if they want to do that and want to rely on an efficient implementation, they can use VVenC as a basis for their extensions, or let's take scalable extensions. If people want to extend that with scalable coding, that's a good basis to do that. And if they bring it back, even better, right? That's the idea. But the license, the software license is as such that you could use it in your product. You do not need to disclose your source code if you use it in your product. So we really made it very simple for people to just use it to deploy VVC as a standard.
That's very nice.
What we already get from feedback from the community, and that is super nice also for us and everyone working on that to see, is fixes, suggestions, improvements, merge requests. So people are already starting working with that and giving back fixes and improvements. That's really nice to see.
That's very cool. So is there anything new that is coming out in the roadmap, if you're allowed to reveal it? Any exciting feature that we can look forward to?
Should I take this one? Yeah, so yes, there are many new and exciting features that we're working towards. So as I already mentioned, we're gonna be releasing even better preset configurations with some new speedups. So mostly towards the faster and fast presets. Those are gonna be getting a lot better, but also in the slower and slow part, there are gonna be some minor improvements. Our multi-threading, for me, it's the feature for the 0.3. It's gonna be way better. So if you run it with like 8 threads, so something a modern workstation should have, it will run basically like 2 times faster than the previous version.
That's huge.
With the same number of threads. So I'm very excited about that. Like we're almost there to start, measuring our encoding times, not in relation to like VTM or HM, but rather like in FPS or something. So
cool.
Very excited about that. We're also gonna, every part will have improvements. Our rate control, the P adaptation, those are going to be getting much better. So like the subjective quality will get better. And also there are a few like a few versatile application aspects that are going to be included, but well, let's not go into detail there just yet.
Yeah, but maybe just to add a point on that, because that is something that will be also released soon, and the context of that is one of the versatile features of VVC is reference picture resampling. So that allows you to reference pictures from previous pictures that have a different resolution. So that's key for adaptive streaming when you have resolution change. And also, we came across your article about open GOP, closed GOP, and so you already digged a bit into that. And that's exactly the point that was not covered before. So really open GOP with resolution change, although open GOP is about like 8 to 9% more efficient than closed GOP. You cannot use it since the reference pictures would have a different resolution. And this is a big key feature that VVC now enables to resample the reference pictures, and also you could use them. And this is there are a lot of more of these features that do not show up in these coding efficiency graphs or sub pictures. So you can also chunk your spatial or spatial regions of your picture. You can chunk into network units that you can already transport. So that enables first directly access in the bitstream, some kind of random access within a picture. It's good for 360 video, and also low latency. So you can already send out packets that contain part of the picture. And this is something that is, I'm coming more from the compression coding algorithm point of view, but thinking about these versatility features also for terms of latency and transport aspects in the systems layer, that is also a really exciting feature of VVC. So being able to have these sub portions of a picture being encapsulated in a data packet that can be sent out. So that's also an amazing feature.
Actually, very interesting. Yeah, but that does bring in loss also into the question. Like, what happens if that small sub picture gets lost? So error recovery becomes a very interesting research topic. You could do an entire PhD on that, I think, just recovering a sub picture. But when you mentioned all this, sorry, go ahead, Adam.
Just to comment on that topic, still recovering a sub picture must be much easier than recovering a whole picture, right?
That's true.
So think about that.
Suddenly my mind went back to HEVC and interlaced. So are there any surprises with interlaced compression and VVC? Any retrofitting like we have to do it in HEVC, or things are going to work?
I guess the interlaced game is pretty much played. So nothing new there, but it's basically what we the support that you have in HEVC is maintained, and I'm not sure whether there was one or two things that needs to be corrected at later versions of HEVC. I think that something rings a bell.
From the DVB spec, I think it said
exactly
they had to be in the same order in display and decode. So that kind of messed things up.
And so this is carried. So this fix is carried over into the first version of VVC. So I guess the interlaced part is done.
Yeah, people will be happy as long as the same fix is carried over. I think it's
cool. Exactly.
Yeah. So I guess my last thing that I wanted to ask you is a little bit more of a philosophical question, which I said. Every generation of codec says, hey, we're going to give you 50% more compression efficiency at 50% more complexity. And then the complexity keeps growing and compression efficiency obviously grows. But So I wanted to get your thoughts on designing algorithms. I mean, this might not be related to codecs itself. It might just be more of a research question. But how do you design codecs keeping encoding complexity as one of the factors? I can always go from macro blocks to quadtree, increase the complexity, improve the efficiency. But then I didn't think even one bit about the complexity. But somebody else down the line, the guy who programs, Adam, has to, he gets scared. He's like, hey, how do I program this? How do I make it run in real time, especially for live compression? And like I mentioned the other time, LCVC, which is a new concept fundamentally to our industry. So how does complexity factor into research and when you propose things at standardization bodies?
So yeah, that's a very important factor. Also, for HVC we wrote a paper on complexity, which has one sentence in the introduction saying complexity is a very complex topic, and that gets to the core of that. So it's hard to generally discuss. It's very implementation specific, as you say. If you do software implementation, if you ask Adam what's his take on complexity, he has like software complexity running on x85, x86 CPUs in mind. If you ask guys from Umbrella or some other chipset manufacturers, they have like very different, more memory bound problems with complexity and so on hardware. So this is but if you take the bottom line, it's okay to be more complex since we have more computing power, and also we have tools that allows us to deal with the increased search space that more options that the more options a new codec provides. And there you have to take into consideration two parts of coding tools. The first part are implicit tools. What does that mean? It means that it's you apply an algorithm and it compresses your source video, and the decoder would do that as well. So that is pretty symmetric, encoder decoder. Then you have and this is easy. So this really gives you gain and does not increase the encoder search space. So this is very nice, and this is also what we have factored into our VVenC development. So these are the tools that we enable first for the fast modes, because they do not require advanced search strategies because you do not search. Then there are tools like motion vector, very simple example. So you need to search for the best motion vector, right? And this can be arbitrary complex until full search, where you check every sample position. And there it's super important to have a smart search strategy that, and now we come to the possibilities of the new tools that we have nowadays, can be data driven. So you can analyze your input signal, your input data, and based on that characteristic, you can already narrow down your search space to a very manageable amount. So although theoretically you introduce a tool that, as you mentioned, quadtree, multi-type tree, and whatever kind of tree combinations you want to have, exponential growth of product space, that is super complex. However, if you have smart ways to analyze your signal to narrow it down to a reasonable amount of options you need to check at the encoder, it's not that bad, and it still provides you the benefit. So this is key here. And also in the figure I was just showing, you compare with for example, X265, the state-of-the-art HVC codec, fast one. Then we can show with the same speed, with the same frames per second, you can get a higher efficiency with VVC. And this is why we have this implementation. So you can take a reference software, you can compare reference softwares, then it's like factor X to get the efficiency, like 10 times. But this is only part of the picture. If you have a real optimized implementation, let's take VVenC. and compare that to its predecessor standard, HVC, with some other optimized implementation, X265, and you say, what can you squeeze out of that VVC standard for the same processing time? And if that's a compression gain, then you know that's good. Then the last point you mentioned with regard to LCVC and other schemes that are some enhancements, low complexity enhancements of a codec. I haven't digged deep into these techniques enough to make a comment there, but certainly this is it shows that complexity is of concern, right? So people are taking that into account, and of course, if you for example, you do encoding in the cloud and you need to pay cloud instances on whatever cloud services you use, they are not for free. Of course, if you have 1 week of cloud rent versus 2 weeks of cloud rent, that makes financially different. So it also needs to be factored in commercially. So this is it's still relevant. But with the VVenC, we've shown that you can keep most of the VVC efficiency that is promised by very slow reference software in an optimized implementation. So that's the good news.
So that actually kind of probably leads into pre-processing a video playing a very, very crucial role. I guess as codecs get more complex, your pre-processing, and even before you encode one frame or one pixel of video, the amount of work, the more work you can do before probably dictates how much less you might have to do during compression. I mean, just off the bat, if you can detect it's a black video and the next one is a black frame, hey, just skip it, go ahead. That's the most naive form, I guess. But do you think that's a good place for a lot of machine learning and such neural networks to be kind of retrofitted in at the pre-processing stage? I don't know about your thoughts on actual compression, but
yeah, that's a very good point, and I would also play that ball to Adam to explain a bit. That's what the purpose of VVenC is, because we are more in the core compression domain. With regard to pre and post processing, we designed VVenC having specifically these codec agnostic frameworks in mind. But Adam, maybe elaborate a bit more on that.
So again, there are a few points to look into here. So we actually have like a pre-processing step that we ported from VTM. It's a bilateral filter that basically enables the codec to make more optimal decisions. And then when you go into machine learning aspects, there is always the factor that, when you apply machine learning on VTM, VTM is so slow that any added complexity doesn't show up. But if you go into VVenC, like preset faster, it's actually pretty fast already. And, inference in machine learning also costs time. So, if you put it in there, you need to factor in your trade-off, how much time you need to spend, how much time you save, and at what cost with regard to the BT rate. But still, we are looking into those methods, but we also see that with the kind of approach that we've been taking, we actually don't need so much of the pre-processing, because if there is an easy decision to be taken, the search algorithm that we have will know to take it. We don't need to pre-process the video to know that the algorithm should take a specific decision. So like in case of a black frame, the cost for just skipping a block will be so good that the algorithm would know not to look any farther. So yeah, that's the first or the first 2 points. Next, with regard to some more elaborate pre-processing steps. So VVenC is, as Ben mentioned, it is a core codec. We want to be able to provide people with a in their pipeline with the step of compressing the stuff. But of course, there are super interesting things you can make. Like another pre-processing step or some kind of pre-analysis that can be, also fed into the encoder, maybe some kind of region of interest detection. But this is more like encoding framework. This goes beyond the core encoder, which we want to provide with the VVenC.
Right, because things that I've kind of toyed with in my head is, suppose you have the home shopping network or you have Cartoon Network, which just plays the same thing 24 hours, right? You could provide hints to the next 1 second. Just saying that, hey, the previous 1 second used this as the search region and this as their QPs. Probably that helps getting a slight bit of a head start instead of searching a lot. But we already have that in a different way. So
one aspect to mention here, we have our QP adaptation, which basically analyzes the video all the time, also temporally. So it analyzes the temporal activity and adapts the bitrate distribution between the frames and within a frame to optimally allocate the bitrate for the parts that the eye will see. And basically what we could do, we could boost this analysis with the information from the previous frames. But for now, this is like the complexity of this algorithm is so low that there's no point for us right now doing this. And if we were, if we talk like a broadcaster who has a very specific kind of content, then again, we're at the level of, full compression pipeline, which kind of goes beyond the core codec. Even if you would build in some hooks into the core codec to respond to the feedback from other pipeline steps, we only have so much manpower, and there are still so many interesting topics, in the engineering and research within the core codec that this is our focus. We don't want to lose the focus.
No, like you mentioned, if you have kept the software design flexible enough for people to plug in their different use cases, I would say, that's just brilliant.
So this also is one other thing we would like to see is having also VVenC inside multimedia frameworks like FFmpeg, because these multimedia frameworks provides such a huge set of tools. Let's say MP4, MKV, multiplexing, pre-filtering, all these the whole filtering pipeline, and to have that there, that's amazing. So this is what we envision to VVenC as a core encoding compression component, and everything that you consider as post-processing, pre-processing, and non or codec agnostic improvements. So things that you can apply to every video codec. This is something I see as a very important factor in such a framework. And so I really like these combinations of having a powerful framework with core compression components, where I see VVenC as one of them.
Fantastic. I guess that brings me to the end of our discussion. Is there anything else you would like to add? The floor is all yours, Benjamin and Adam.
Adam, do you have something? I guess you mentioned that we are about to release a new version within the next month that gets even a little bit faster. And I guess we have some exciting projects that we still need to finalize. And so stay tuned. We will hopefully have some more exciting announcement this year.
Fantastic. Thank you so much for taking the time out of your schedules to join me here. I think this has been very educative for me and hopefully to a lot of people on what goes on inside Fraunhofer HHI, what goes on inside a codec development and the thought process. It's very different from just implementing a spec, the actual research behind it. So thank you very much. If people have any questions to either Benjamin or Adam, you can either reach out to me. I'll also, if it's okay, link their LinkedIn profile so you can reach out to them directly. So until next time, thank you very much and stay tuned.
Thank you. It was a pleasure. And it really didn't feel like 1 hour. So it's,
it's been an hour already.
Yeah, it's like time flies. That's very. Always enjoy talking to you who are already deeply familiar with the technical stuff. Real pleasure. Thank you.
Thanks, Adam. Thanks a lot.
Thanks. Bye.